Now that we know how to create the composition of two functions, we can look at evaluating those compositions, which really is just reading function notation. Now what we want to do is look at reversing this process. If we can take two functions and create a composition out of them, then we can reverse that process and decompose that function into two simpler functions. Right now we're more or less doing this for the sake of doing it. But when you hit calculus later on, business calc later on, this is going to become a critical step in knowing how to work a number of problems in that course. Being able to identify that you have the composition of two functions and knowing how to break that into its two different components. In example 5, we're given the function h of x, and what we want to do, or what we're told, is that if f of x is equal to x squared, we want to find the function g of x. So here we're given half of the answer. F of x is equal to x squared. What we want to do is determine with that information what is g of x. So we're doing this in the form f of g of x. So g is the function that's being plugged into f. So what function would we have to plug into x squared to get this expression x plus 6 squared? Whichever function comes second, we can think of that as the interior function. So in this case, what we have is an interior function of x plus 6 being substituted into x squared. And that's how we're getting that expression, x plus 6 raised to the second power. In example 6, we're still dealing with a function that we want to express in the form f of g. So g is the interior function, and we're told that g of x should be x plus 7. We want to think about what function are we plugging this x plus 7 into to get 1 over x plus 7. The x plus 7 isn't being raised to a power, it's not being multiplied or square rooted, it's just the denominator of this expression. So our function f of x should be 1 over x. Because if we replace that x in the denominator with x plus 7, we would have this function k of x. In the last several examples here, we want to complete that same process, but now we're not being given the hint of what one of our first functions is, except to be told that neither f nor g is equal to x, or in example 8, we're told that this is two non-trivial functions that we should decompose into. So it's just eliminating the really simple cases. What we want to do is break this given function, x plus 2 squared, into two different functions that were pushed together to create this composite function. There are a couple of different ways to think about this. One is to kind of squint your eyes at this expression and think about what it kind of looks like. We have some quantity being squared. So if you can see it, that tells us that this outer function, f of x, should be x squared. And once you know that that's x squared, you can identify this interior function, g of x, which is x plus 2. So x plus 2 would have to get plugged into x squared to give us this composite function, m of x. The other way to approach it is just the opposite order. Start by identifying what you think the interior function is. If there's an expression in parentheses, that's a good idea to pay attention to. So we're not worried about what the bigger overall function is, we're just focusing on this internal part. So it looks like g of x is being plugged into something. So then the question is, what is that expression being plugged into? In this case, that would have to be x to the 6th power, because when we substitute that expression g of x into x to the 6th power, we would get the function that we're given in example 8. In example 9, we don't really have a kind of as clearly an interior function because nothing is being expressed in parentheses. But we can always think of a fraction. We can always think of putting both the numerator and denominator in parentheses if we wanted. It doesn't change the expression. And in this case, it can help us see that that interior function could be x cubed. And our outer function, the function that we're plugging x cubed into, would be 1 over x. In example 10, we could think of this idea of squinting again a little bit. And in some cases, there are different answers for these problems depending on how you look at the function. But in this case, what we have is 1 over something squared. So if I made my function f of x equal to 1 over x squared, then my function g of x would have to be x minus 7, because I would have to plug x minus 7 in for x to get that result. In this case, we could come up with an alternate answer, because maybe you look at this and instead you see this is 1 over some quantity. So we could let f of x be 1 over x. If f of x was 1 over x, then g of x would have to be the quantity x minus 7 squared. This pair would still match up when we plug g of x into f of x. We would end up with that composite function we started off with.